welcome back to my channel. Today is a beautiful day and a great time to learn some math. I have a motivational quote for you today, and my quote is, wanting something is not enough. You must hunger for it. Your motivation must be compelling in order to overcome the obstacles that will invariably come your way. And this is a quote by Les Brown. So you can't just want it, you gotta hunger for it, you gotta work for it, you gotta fight for it. And you can do whatever you put your mind to as long as you focus and don't let nothing distract you. All right. So in this video today, we're going to talk about polynomials. I'm going to introduce you to what a polynomial is and how to do some things with polynomials. So it's a very basic introduction to polynomials. So let's jump right in and talk about polynomials. So just what exactly is a polynomial? A polynomial is an expression of the form a(n) x to the n plus a(n) minus 1 x to the n minus 1 plus a1 x plus a9. Now I know that probably looks foreign to you, but it's okay. It's not that bad. I'm gonna break it down for you. All right. So this is just saying that it is a combination of different terms. These are called terms, where you have a variable and you have a number in front. So these a(n)s, these a's, they represent the coefficients, and then these x's represent the variable, the n's represent the exponent. And this is just saying that in standard form, it's written with the biggest exponent first, and then you decrease the exponents by 1 each time. Now you might not have a place for every exponent less than that highest one, but if you do, you want to write them in order from biggest exponent to smallest exponent. So basically a polynomial is a finite sum of terms. Here's an example of a polynomial: 4x to the third plus 6x squared minus 5x plus 8. So this is an example of polynomial. It's a finite sum. Finite means you can count how many it is. Sum means you're adding together, even though subtraction, remember, subtraction is really the same as addition. You're just adding a negative number. So you have a finite sum of terms. Each term has a number and a variable with an exponent. And even in the absence of a variable, this is like saying x to the 0 power. So we call each of these that's separated by a plus or minus sign, we call these terms. So these are called terms, and there are 4 terms in this particular polynomial. Each term has a coefficient and a variable. So the number in front is called a coefficient. So my terms are 4x to the third, 6x squared, negative 5x, and 8. Those are the terms of this polynomial. Now the coefficients are 4, 6, negative 5, and 8. 4 is the coefficient of this term, 6 is the coefficient of this term, negative 5 is the coefficient of this term, and 8 is the coefficient of that term. So the coefficient is the number in front. Alrighty, so we got our polynomial, we got our terms, we got our coefficient. Now, there's also what's called a leading coefficient. The leading coefficient represents the term with the highest exponent. So our biggest exponent here is 3, and usually it's written in the front, but that is not always the case. So our biggest exponent here is 3. So this term would be our leading term. Sorry, I should have wrote that one first, but it's okay. Our leading term is the one with the biggest exponent. So 4x to the third is our leading term because it's the term with the biggest exponent. The leading coefficient is the coefficient of that term. So our leading coefficient here is 4. Alrighty, so these are my terms. Here are my coefficients of each term. Here's the leading coefficient. Here's the leading term. And then one other thing we want to talk about is the degree. A polynomial has a degree, and the degree is just the biggest exponent. So the degree of this polynomial is 3. That is the biggest exponent in the polynomial. All right, so these are some basic characteristics of polynomials that we often refer to, and it is important that you know these characteristics. In addition to those characteristics, another way that we classify polynomials is based on how many terms there are. So if there is only one term in the polynomial, we call that a monomial. if there is two terms, so here the prefix mono means one. If there are two terms, we call that a binomial. The prefix bi means two, and then guess what we call it if there are three terms? If you said trinomial, you are correct. Trinomial, because the prefix tri means three. So this is one way, or another way we classify polynomials based on the number of terms that it has. Another way is based on the degree. We won't specifically talk about that now. We'll talk about that later with polynomials. But for this, in this video, in the introduction to polynomials, we just want to talk about whether it's a monomial, a binomial, or a trinomial. For example 1, we want to name the coefficients for each term and determine the number of terms for each of these polynomials. So our first polynomial is x minus 6x to the fourth plus 3. So remember, your terms are separated by plus and minus signs. So that means this is a term, this is a term, and this is a term. So my three terms would be x minus 6x to the fourth and 3. Those are my three terms. So if you want to separate them with a little line, you can do that. And then, so how many terms are there? There are three terms, because it asks us to figure out how many there are. So here we have three terms. And then it asks us to figure out what is the coefficient for each term. So since there's no number in front of this x, there's an understood 1. So the coefficient of that term would be 1. The coefficient of this term would be -6. And the coefficient of this term is 3. And so that is basically how you would identify the terms and write the coefficient for each one. Now for this particular polynomial, part B, our terms are 5 and -v to the third. So that means now we have two terms, 1, 2, and then the coefficients, that will be 5, and then this one there is no number right there, but there's an understood 1, so that would be -1. So this is basically how you would list the terms and the coefficients. So now we want to talk about like terms. What are like terms? So terms are considered alike when they have the same variable and the same exponent. Okay, so for example, x and 5x. These have the same variable, the same exponent. The exponent of that variable is 1. Those are considered like terms. 3x to the fourth and -2x to the fourth. Those are considered like terms because they have the same variable and the same exponent. And then let me give you one more. xy squared and 3xy squared. Those are considered like terms because they have the same variables and the same exponents. So we want to talk about combining like terms. So what does that look like? That means any terms that are alike, you can bring them together. So let's look at some examples on how to combine like terms. In this second example, we want to simplify by combining like terms. So starting with part A, we have -4x to the third plus 6x to the third. These are both considered like terms because they both have x to the third. So the way we would combine those is basically we would combine the -4 and the 6. And the x to the third is the same in both of those. So what is -4 plus 6? -4 plus 6 is a positive 2. It's like saying I owe somebody $4. I gave them $6. That means I gave them $2 extra. So that's a positive 2. So this will be 2x to the third. So that is how we would combine those. Part B, we have 9x to the 6 minus 14x to the 6 plus x to the 6. We have three different terms, but they all have an x to the 6. So they're all considered like terms. So we would combine those by doing the 9 minus 14, and this is considered a 1, so plus 1, and that's x to the 6. So 9 minus 14 is -5. -5 plus 1 is a -4. And then for part C, it has a fraction in it. I know y'all don't like fractions. Y plus 2/3 y, but it's not bad. Remember, fractions are like those family members that we love dearly. We just can't stand to be around them. So this ends up being, these both have y. So this ends up being 1 plus 2/3 y. And in order to add these, you have to have a common denominator. So you will make this 1 have a denominator of 3. And if you write 1 as a fraction, that's 1 over 1. And if you wanted to have a denominator of 3, you will multiply top and bottom by 3. So this will end up being 3 over 3 plus 2 over 3y. Since the denominators are the same, then you can add the numerators. And this will give you 5 over 3y. And so that is this expression combined, these like terms combined. Okay, example 3, we want to simplify and classify the polynomial. So when they say classify, it means classify it as a monomial, a binomial, or a trinomial, the simplified polynomial. So if we start with part A, 2x to the third plus 5. So you will simplify by combining any like terms. But do we have any like terms here? This has an x to the third, but this one does not have an x to the third. So these cannot be combined. So this cannot be simplified, or that is the simplified version of the polynomial. It's just 2x to the third plus 5. How many terms do we have? We have 2 terms. So since it's 2 terms, that would be classified as a binomial. All right, so that's part A. Part B, we have 6x minus 8x plus 13x. All of these have x's in them, so they all can be combined. This would be 6 minus 8 plus 13. 6 minus 8 is -2. -2 plus 13 is 11. So this would be 11x. It simplifies down to only one term. So since it's one term, that would be a monomial. And then on part C, we have 4xy minus 5xy plus 2xy. All of these have an xy. So these are all considered like terms. So that would be 4 minus 5 plus 2xy. 4 minus 5 is -1. -1 plus 2 is a +1. So this will be a +1xy, which we just write xy. Again, that has only one term, and that is also considered a monomial. So I also want to go back, it didn't ask us for this, but I want to go back and give the degree of each polynomial, because this is something that you may be asked. So the degree, remember, is the highest exponent. So in this case, the degree would be 3, because 3 is the highest exponent. In this case, the degree will be 1, because there's no exponent on that x, there's an understood exponent of 1. So that will have an exponent of 1. And so if you have more than one term, then what you have to do is add those exponents together. So the exponent on that x is 1 and the exponent on that y is 1. So when you add those together, 1 plus 1, you get 2. So this would be considered a second degree polynomial. Very last thing we want to talk about in regards to polynomials in this video is how to evaluate polynomials. So when you talk about evaluating polynomials, what you're doing is you're plugging in a number for the variables, and your final solution will be a number. Okay, so when you evaluate a polynomial, you're going to end up with a number as your answer, not a simplified expression. So let's look at this example. Example 4, we want to evaluate this polynomial, 3x to the 4th plus 5x to the 3rd minus 4x minus 4 for x equal to -2. That means we're going to replace every x with a -2. So this becomes -2 to the 4th, 5 times -2 to the 3rd, minus 4 times -2, minus 4. And we want to evaluate this and see what it equals. So you have to use order of operations. Please excuse my dear Aunt Sally. Parentheses first, followed by exponents. We don't have any parentheses. Although these are parentheses, these are used to separate this -2. It's not a set of operations in parentheses. So we would skip parentheses, we would do exponents next. So that means I would take -2 and raise it to the 4th power. -2 times -2 is 4, times another -2 is -8, times another -2 is +16. So that will become +16. -2 to the 3rd is -8. That's -2 times -2, which is 4, times another -2 is -8. And then I don't have exponents here. So that will be all of my exponents. So please excuse so multiplication would be next. So I'll multiply. So 3 times 16 is 48. 5 times -8 is -40. -4 times -2 is +8. And minus 4. So I don't have any division. I have plus and minus left. And anytime you have either subtraction and division together, or addition and, no, I'll take it back. Anytime you have multiplication and division together, or addition and subtraction together, then you just work from left to right. So I have addition and subtraction, so I work from left to right. 48 minus 40 is 8. 8 plus 8 is 16. So if y'all need me to write it, that's 8. 8 plus 8 is 16. 16 minus 4 is 12. So your final answer would be 12. So this is how you would evaluate a polynomial. You'll plug in a number for the variable and you'll end up with a number as your answer. If you have any questions whatsoever over polynomials, be sure you include them in the comments below. I will respond. If you like this video, if it helped you, make sure you hit the like button. And if you haven't already, make sure you subscribe to the channel, show some love, and I will see you in the next video. So thank you for watching.